NASA found a world that breaks the rules. A moon that should have frozen solid billions of years ago. A world too small, too far from the sun, too cold to still be alive. And yet, it erupts with more volcanic fury than Earth. Lava fountains blast hundreds of kilometers into space. Entire mountains rise in sudden violent bursts, and gravity alone is tearing it apart. Scientists looked at the data, ran the numbers again, and realized something was wrong. Because by every model we have, this moon shouldn't exist like this, and yet it does. This is Io. And what NASA discovered here changed how we understand planets forever. Far beyond the warmth of the sun, past the asteroid belt and into the deep outer solar system, Jupiter reigns as a giant among worlds. It is so massive that it could swallow all the other planets combined and still have room left over. And orbiting this gas giant is an entire kingdom of moons, nearly 100 known today. Most are small, irregular fragments, cold, silent, inactive, but 4 of them stand apart. In 1610, Galileo Galilei pointed one of the first telescopes ever built toward Jupiter and noticed tiny moving lights beside it. He realized they weren't stars, they were worlds. Today we call them the Galilean moons, Ganymede, Callisto, Europa, and Io. The outer 3 are dominated by ice. Ganymede is the largest moon in the solar system. Callisto is ancient and heavily cratered. Europa hides a vast ocean beneath a frozen shell, one of the best places to search for alien life. And then there is Io. It orbits closer to Jupiter than any of the others, just 350,000 kilometers above the cloud tops. That's only slightly farther than the distance between Earth and our own moon. But similarity ends there. Io is almost entirely rock and metal. It contains almost no water. In fact, it may be the driest object in the entire solar system, even drier than Mercury, the planet closest to the Sun. And yet Io is not frozen. It is not dead. It is the most volcanically active world we know. More than 400 active volcanoes cover its surface. The first sign of this came in 1979, when NASA's Voyager 1 spacecraft flew past Jupiter. Even with low-resolution cameras from nearly 20,000 kilometers away, Voyager detected something astonishing. 9 separate volcanic eruptions were visible at the same time, plumes rising high above the surface, lava spreading across alien terrain. At first, scientists thought it must be a mistake, but it wasn't. Io was alive, and the question became, how? Because sunlight at Jupiter's distance is weak. Temperatures on Io's surface plunge to minus 130 degrees Celsius outside volcanic regions. There isn't enough solar energy to power this kind of activity. So where does the heat come from? The answer is gravity. This moon lives in one of the most extreme gravitational environments in the solar system. Jupiter's immense mass pulls on the moon with overwhelming force. But Io doesn't orbit in a perfect circle. Its orbit is slightly elliptical. That means its distance from Jupiter constantly changes. As Io moves closer, Jupiter's gravity increases. As it moves farther away, the pull weakens. This constant change stretches Io. Literally. The entire moon flexes as it orbits. And Jupiter isn't acting alone. Europa and Ganymede also tug on Io just enough to prevent its orbit from stabilizing. The result is a gravitational tug-of-war that never ends. Every 42 hours, Io is squeezed and released. On Earth, our moon pulls on the oceans and creates tides that rise roughly half a meter in the open sea. On Io, Jupiter's gravity lifts the surface by as much as 100 meters. Not water, solid rock. The entire moon bulges outward, then collapses, then bulges again. That repeated flexing creates friction inside the moon's interior, and friction generates heat. This process is called tidal heating. It turns Io into a gravitational furnace. Unlike Earth, Io doesn't have tectonic plates drifting across its surface. Instead, its crust fractures under stress. Cracks open. Magma forces its way upward. Eruptions blast lava dozens of kilometers into the sky. Sulfur-rich plumes can rise hundreds of kilometers above the surface. The moon is wrapped in a thin atmosphere, made mostly of sulfur dioxide, constantly replenished by volcanic eruptions. As sulfur falls back to the surface, it paints Io in extraordinary colors. Brilliant yellows from crystallized sulfur, white and blue patches of frozen sulfur dioxide, deep reds marking fresh volcanic hotspots. It looks unreal, almost artificial. But the strangest discoveries came decades later. When NASA's Juno spacecraft arrived at Jupiter in 2016, its mission was originally focused on studying the gas giant itself. After completing its primary objectives, Juno was redirected toward the Galilean moons. In December 2023, and again in February 2024, Juno flew within 1,500 kilometers of Io's surface. The images stunned scientists. Towering mountains rose from the surface, some reaching 18 kilometers high, nearly twice the height of Mount Everest. But they didn't form mountain ranges. They stood alone, isolated spikes piercing the sky. Without tectonic plates to push crust upward slowly over time, these mountains must form suddenly. The leading theory suggests that when massive lava lakes collapse inward, pressure forces nearby crust upward in violent bursts. Imagine if every time a sinkhole opened on Earth, a mountain instantly rose beside it. That is Io, a world in constant collapse and rebirth. And here's the paradox. Moons this small are supposed to cool over time. They should become geologically dead. But Io refuses. As long as Jupiter keeps pulling, as long as Europa and Ganymede keep tugging, Io will keep burning. And that's why some scientists described it as a moon that shouldn't exist, because it defies our expectations of how small worlds evolve. It shows that gravity alone can power planetary-scale chaos. And yet, despite its importance, no mission is currently scheduled to return specifically to Io. Future probes will focus on Europa and its hidden ocean, because oceans might hold life. Io almost certainly does not. But in many ways, Io may be just as important. It reveals what happens when gravity becomes a destructive engine. It may even resemble what early Earth once looked like, before oceans cooled its surface and stabilized its crust. Out there in the cold darkness near Jupiter, a moon is being torn apart by invisible forces. It should be frozen. It should be silent. Instead, it is alive with fire. And it continues to challenge everything we thought we knew about how worlds are supposed to behave. Io shouldn't exist like this, but it does, and gravity is the reason why.